Good evening, excellent biology students. Hope you are doing fine, and I hope you had a good day. So please let me know if I am audible. Please let me know if I am audible. Otherwise, good evening. Wonderful, 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 wonderful. Okay, so I'm audible. Okay. So in tonight's live class, what I'm taking you back to grade 10. Okay. In tonight's live class, I'm taking you back to grade 10, and we're going to look at one of the most important topics that you should never forget. Yeah. So that's what I'm going to be covering in today's live class. So let's just wait for others to join before we can start. Otherwise, I hope everything is clear on your end. I'm glad that I'm audible. I hope you are able to see what is on the screen. So exams are almost here. Your exams will be written on the 29th of July. How are you feeling? How are you feeling concerning your exams? How are you feeling concerning your exams? Tell me, how are you feeling? Share your feelings. How are you feeling now that we are days away from the exam? How are you feeling? I shouldn't even mention it. Mention it. Eh? Yeah, they are coming. Eh? You don't even want, when your exams are near. One thing that I can say everyone experiences at some point is that you won't even want it to be night for you to sleep to go to the next day, because you know to say, when I sleep, I'm getting closer to my exam, especially if you're not ready. But there are some who they just want to write and forget about this and move on. Otherwise, how are you feeling? Others are feeling anxious. Asa is ready. How are you feeling? Yabwera my exams up. Yeah. Wills is scared. Is it Wills? Yeah, Wills. Sivoyopa vivintu. Sivoyopa. Salome, I don't feel ready. Wiza, scared, can't even lie. One thing that I know when it comes to exams is you can never be ready. You can never say hapana fikapo. That is why, and one thing that you need to know is that you can't know everything. You just have to pray that what you know is what comes. Because even the examiner, they won't bring everything. They won't bring everything. So I hope what you already know at the moment, you know it 100%. So if you know, let's say, 8 topics, I hope you know all the eight, like those 8 topics, like 100%. Not even the things that you don't really know them. That becomes a challenge. Sir, is it possible to pass without section C? Actually, biology has got 2 papers, in fact, 3, of which paper 3, all of you wrote paper 3, which was a practical paper. So it has got 2 papers, paper 1 and paper 2. So paper 1, it's multiple choice, and then paper 2, it is it has got 2 sections, section A and section B. On my TikTok account, I shared the topics that are covered, but I think I would maybe type a document to show you to say, oh, from question 1 to question 5, these 5 questions are based on this particular topic, and that is for paper 1. Then question 10 to question 11, I think I'll do that. Otherwise, paper 1, it's multiple choice, and then paper 2 has got 2 sections, section A and section B. Section A has got 5 questions, of which the 5th question is always genetics. So whether you like it or not, you will find a question based on genetics, which will be question 5. And then section B, it is essay writing. I'll share a video after this live class. In fact, let me just share it right now, where I was explaining how to write an essay. So you will find a video in the group where I was sharing how to write an essay. So yeah, you need to know that. So section paper 2 has got 2 sections, section A and section B. Section A has got 5 questions. Then section B is based on essay questions. So I have shared a link on how to which will take you to YouTube, and you find a video where I was explaining how to write an essay. Otherwise, don't be scared. Don't be scared. Yeah, you've been here before. You've been here before. Okay. Otherwise, registration for July has started. So for those who have registered and they've been added to the group, you receive videos for the entire syllabus. So I'm going to share videos for the entire syllabus so that you can be participating as we are going through past papers. So in July, in the July group, there is no assignments. We're just going to be going through past papers, except for week 1. So week 1 of the July group will be looking at cells, we'll be looking at ecology and genetics. And then week 2 of July, in week 2 of the July group, in week 3 of the July group, we'll be going through past papers. So make sure that you register for the class. Okay, make sure that you register for the class. You do not want to miss. So those who are going to register, I'm going to send videos for the entire syllabus so that you can watch them and so that you can participate, as I'll be going through past paper questions for paper 1 and paper 2 to be full paper. And then over the weekend, which is this Saturday and Sunday, we're having our mock. So I hope you are ready for that mock. Yeah, prepare yourselves for that mock. Otherwise, in tonight's live class, I'll be teaching um, this topic, which is easy. It's an easy topic, but there are some students who find it hard to understand. It's a simple topic. It's a simple topic. We've done it before. For if you are with me from October up to now, this is a topic that we've done before. Diffusion. Diffusion. This word diffusion, you come across it in many topics in biology. So I hope we know this topic. So one thing that I can say before I even start teaching is if you know 5 topics at the moment, make sure that you truly know those 5 topics. Don't know, I hope you do not know only like 40% of the 5 topics. What I mean is, if you know osmosis, I hope you know everything about osmosis. I hope you know 100% of the little topics that you know at the moment. I know there are some students who started late classes because online classes they start in October, but there are some who obviously, due to different reasons, they started late. So the topics that you know, I hope you know 100% of those topics. One thing that you shouldn't do is panicking. Just take it easy, take it easy. Just take it easy. Breathe. This is not new. Breathe. Breathe. Don't be scared. If you feel blank, it's just a feeling. I'm sure you've been learning. I'm sure you've been watching the tutorial videos. I'm sure you've been studying. So, sometimes your feelings can even lie to you, especially if you're in an exam room. You feel like you're blank, but when you sit in that exam room, you will just be surprised how the information will start and offload in your from your brain. So just breathe. I should predict paper 2 topics. I will do that prediction. I will do that prediction soon. But genetics, definitely it will be there. And do not undermine these 2 simple topics. Diffusion, homeostasis, excretion, responses, health and diseases. Do not undermine these small topics. They usually come. Paper 1 covers all the topics, all of them. So do not undermine these small topics. Make sure that you know them. Because one thing that you should never do is looking down in a particular topic. Let me just skip. Let me go to the big boys. Do not undermine small topics. They can shock you. So small topics shock you. So do not undermine these small topics. Know them. Know them. Self-specialization. Do you know what self-specialization is? Eh? When it comes to metabolic reactions, do you know them? Catabolic, anabolic. Do you know those things? So do not undermine these small topics. Do not undermine the microscope. Do you know it? Do not undermine the dentition. Don't undermine these small topics, my students. Do not. Trust me. Okay. Oh, so Asa was asking, is it possible to pass without section C, like without writing an essay? So under essay is important. Essay is very important because biology is tricky in paper 1. Paper 2, it's not that tricky. Paper 1 is tricky. But for you to pass, you definitely have to write an essay. Just have to. Yeah. All right. So in this class, I'll be looking at this simple topic, diffusion. Okay. And then in tomorrow's live class, I'll be going through some past paper questions. Yeah. So I think I can start. Objectives, we'll look at the definition, and then we're going to look at the factors that affect the rate of diffusion. Then we're going to look at the importance of diffusion. I think I have got a past paper somewhere. Let me just check. Just a minute. Just give me a minute. In fact, I can use this slide. Yeah. Just a minute. Let me look for another one with a lot of slides here. Okay. Now I don't know if it can even be clear on your end. So we'll be going through past papers in the July group. This is what we'll be looking at. Like the entire full paper, going through it. But there's something I'm looking for. Just a minute. So I need guidance on paper one. It's very tricky. So as I'll be answering those past paper questions, I'll also be telling you how to go about paper one. Otherwise, one thing that I can say is if you panic, it will work against you. Do not panic. Okay? Do not panic. So under diffusion, there are three things that you need to know. Okay? Under diffusion. Number one, the definition. You need to know the definition of diffusion. That's the first thing that you need to know. Number two, the factors that affect the rate of diffusion. Then number three, the importance of diffusion. That's all. That's all you need to know under diffusion. Okay. So what is diffusion? Diffusion is the movement of particles from their region of higher concentration to their region of lower concentration. Simple definition. Diffusion is the movement of particles from their region of higher concentration to their region of lower concentration. In other words, if you are to spray perfume right now, deodorant, and you go into a room, your scent, it will diffuse, meaning it will spread throughout that room. Particles will move from your body to the entire room. Now, how are those particles moving? They are moving by a process of diffusion. They are diffusing from your body to the rest of the room. So diffusion is simply the movement of particles from their region of higher concentration to their region of lower concentration. Simple. Now, what you need to understand is that these particles, as they are spreading out from the source, okay, as they are spreading out from the source, they are moving, and they are moving at a certain speed or rate. Okay, as the particles are diffusing, as they are spreading out from the source, they are moving at a certain speed, of which that speed changes. And there are factors that are going to cause a change in the speed of the particles. Okay, and those are the factors that affect the rate, or the factors that affect the speed of particles. And you need to know those factors. So what are the factors that affect the rate of diffusion? We've got temperature, we've got concentration gradient, we've got surface area of diffusion surface, we've got thickness or distance of diffusion surface, we've got temperature, we've got size of diffusing particles. These are the factors that affect the rate of diffusion. So when you look at temperature, temperature affects the speed of particles that are spreading out. Concentration gradient, it does the same thing. The size of particles, the particles that are diffusing, their size will affect how fast or slow they will move. Diffusion surface also affects the rate of diffusion, how fast particles can diffuse from one point to another. So there are different factors that affect, the rate of diffusion, and they are simple. These are the factors: concentration gradient, surface area of diffusion surface, thickness or distance of diffusion surface, temperature, size of particles. You don't even have to know all of them. If you just know three, that is enough. If you just know three, that is enough. So concentration gradient. Concentration gradient is one factor that affects the rate of diffusion. Now, how? What is concentration gradient, by the way? So concentration gradient refers to the difference in concentration gradient refers to the difference in concentration, okay, of particles between two regions. So if imagine there are two rooms, we've got room A and room B. And then in room A there is smoke. Mwayamba chechusi mu room A. In room B there's no smoke. Already there's a difference, isn't it? There's a difference in concentration. In room A, there is smoke. In room B, there is no smoke. So because of that difference, you find that particles will start moving from room A going into room B. Because there's a what? There's a difference in concentration. So that difference in concentration between room A and room B is what is referred to as concentration gradient. So concentration gradient is the difference in concentration between two regions, and it is what will cause particles to diffuse. Otherwise, if there was no difference, particles won't diffuse in the first place because there's no difference. So particles will get to diffuse, or they will get to move from point A to point B because there is a difference in concentration, because there's a difference. Are we clear? So in the example I gave you, the concentration gradient is the difference in the concentration of smoke. So in room A there is smoke, in room B there is no smoke. There's a difference there. And that difference in concentration of the smoke is what is referred to as concentration gradient. And it is because of the difference that exists which will cause particles to move from room A to go into room B. So concentration gradient is one of the factors that affect the rate of diffusion. So when there's a high difference, particles tend to move faster. So if the difference between two regions is high, then particles will move at a faster rate. But if the difference is not high, particles will move at a slow rate. Another factor is surface area of diffusion surface. This is just the space, okay, the space through which particles will penetrate through as they're diffusing from one point to another. So imagine there's a surface. I'll give an example of for you to understand. Let me give an example of a door and a gate. A door is an opening, right? A gate is also an opening, but a gate is wider than a door. So a gate can accommodate more things than a door. More things can pass through the gate than a door. Why? Because a gate is wide, so it can allow more to pass through than a door. A door can allow things to pass through it. Yes, you can, you as a human being, you can pass through. But can a car pass through the door? No. So you find that a door will be limited. A gate, it's wide. It can accommodate more than a door. And it is the same thing with the surface area of diffusion surface. A surface area is a space. A surface area is a space. And through this space, particles are penetrating. So a surface area is a space through which particles will penetrate as they are moving from one point to another. Now, if the surface area is large, that simply means it can accommodate more particles penetrating through it. But if a surface area is small, yes, it will allow particles to penetrate through it, but not as much as it can if it was large. So the larger the surface area, the faster the rate of diffusion, because now it will take less time for more particles to diffuse. I hope I'm making myself clear. The larger the surface area, the faster the rate of diffusion. Same as the example I gave. If things are going to pass through the gate, they'll be more fast than when things are passing through the door, because the gate is wide, so it can accommodate more things passing through it than a door. So that's how surface area of diffusion surface affects the rate of diffusion. And then now, when it comes to the thickness of diffusion surface, how can I explain it? So when we're talking about the thickness is just a distance. If something is too thick, hmm, if something is too thick, your blanket, you want it to be thick when it's cold, isn't it? Thick blankets keep you warm because they are thick. They are thick. But thin blankets, they can't keep you warm because they are thin. They are thin. Meaning the distance is thin. But if the distance is thick, then that blanket will keep you warm. But if the distance is thin, that means it won't keep you warm. It's not thick enough. So if something is thick, that simply means there's a long distance in thickness. If something is thin, that simply means there's a short distance in thickness. Let me say that again. If something is too thick, that simply means there's a long distance in thickness. If something is too thin, that simply means there's a short distance in thickness. So if particles are moving, they're penetrating through that blanket, which is thick, it will take time for those particles to penetrate through that blanket because it's too thick. But if a blanket is thin, particles will take less time penetrating through it. So what does that mean? The thinner the diffusion surface, the faster the diffusion rate, or the faster the rate of diffusion. So if you cover yourself with a thin blanket or a bed sheet, then you spray perfume as you are covered. That perfume can diffuse out faster than when you cover yourself with a thick blanket and you spray the perfume. That perfume won't diffuse faster out of the blanket if you continue covering yourself with it. Hope you are getting the picture. Imagine you cover yourself with a blanket, a thick blanket, and then you spray perfume, but you continue covering yourself. That perfume, it is highly concentrated in that blanket as you are covered. But it will penetrate through the blanket going to the rest of the environment, but it will take some time because the blanket is thick. But if you cover yourself with a bed sheet, right, and then you spray perfume, you find that particles will diffuse faster. They'll penetrate through that bed sheet faster than they could when you covered yourself with a thick blanket, because the diffusion surface was thick with a thick blanket too. So therefore the distance was long that the particles would take as they are diffusing. Okay, am I making myself clear? Is what I'm saying making sense? Someone to comment if you're understanding, because these things are hard, and such questions, they are the ones that come under essay writing. Ndiye amene amabwera pa ma essay ma question yaso. Ma question yaso aya mabwera pa essay. Now temperature is a different story. When it comes to temperature, if you spray kama perfume, when it is hot, you will find that perfume will spread fast than when it is cold. So if you spray perfume, ngati kwapya umanungila imwe. You want spray a perfume wa John. Everyone is telling you smell nice. Even like, Kash Kanvik, Kash they can tell the scent. Hey, it's hot, Kylie. Mm. That is why when it's hot, it's so easy to tell when someone is smelling, smelling of sweat. It is hot. So you find that the particles of sweat are diffusing faster than when it is cold. When it is cold, can you tell what uyanunga chive? No, you can't. Unless if you are close to that person. But it's hard because when it is cold, diffusion occurs at a low rate, at a slow rate. But when it is hot, we are going to tell Brenda that he didn't bath. So the higher the temperature, the faster the rate of diffusion. Meaning when it is hot, particles tend to diffuse fast than when it is cold. That is why it's advisable to bath when it is hot. And I'm sure some of us, but not in this class, not in this class. Some of other people out there, they don't bath when it is cold. Amachacheka jombo. Eh. You can get away with it when it is cold because you know to say particles they don't diffuse faster. So no one can tell that I'm smelling of sweat. You yourself you can tell because this is your body, but another person can't really tell. But when it is hot, we can tell that they didn't bath. No wonder ka roll on, very important. I don't know if it's roll on or roll on, whatever, but it is very important. So the higher the temperature, the faster the rate of diffusion. Now, why is it so? Why is it that when the temperature is high, particles tend to move faster? The reason is simple. It is because particles gain kinetic energy. Now, kinetic energy, this is energy which is as a result of something moving. It is energy gained as a particle is moving. So when it is hot, particles tend to vibrate at a faster rate. Even when you expose, let's say, if you look at a solid, right? A solid can be changed. It can be converted into a liquid by heating where it melts. Isn't it even going to say melting point? So when you heat up a solid, what will happen? It will be converted into liquid. Why? Because when you expose that solid to heat, particles of a solid will start vibrating rapidly. We know that when you look at the properties of a solid, particles are tightly packed and they vibrate at one position. So if you expose a solid to heat, what will happen is that those particles will start vibrating rapidly. And as they are vibrating, they'll be creating spaces in between. So as they continue vibrating, there will be more spaces in between, leading to a liquid. Because when it comes to a liquid, properties of a liquid are that particles they are not tightly packed. There's some space in between. Okay. So when particles are exposed to heat, they'll gain kinetic energy, which will cause them to move at a faster rate. So that perfume that you spray, me a long time ago, I used to doubt. And the funny thing about perfume is that when you spray perfume, you yourself, you can't tell, you can't get the scent, but people will be getting the scent. They'll be like, yeah, there's perfume here, there's perfume. But you yourself, you can't tell. Funny, it's funny, eh? But yeah, the higher the temperature, the faster the rate of diffusion. And then size of diffusion particles. So the particles that are diffusing, they've got size. They've got a specific size, of which that size affects how they move. I'll give an example. A truck and a sports car. You will agree with me that a sports car will obviously move faster than a truck. Why? One of the reasons can be size. Size can contribute to how fast a vehicle is. So you find that a tractor will be slow compared to a sports car, because maybe a sports car the size is smaller than that of a truck. So the size matters. Size of particles matters. So the bigger the diffusing particles, the slower the diffusion rate. Meaning if particles are big, they will tend to diffuse at a slow rate. But if the particles are small, they will diffuse at a faster rate. Okay, so the smaller the size of particles, the faster the rate of diffusion. So these are the factors that affect the rate of diffusion, and these can come under essay writing. Explain the factors that affect the rate of diffusion. If you were to find this question in an exam, that's how you answer. So these are the factors that affect the rate of diffusion. So diffusion is simply the movement of particles. As long as something is moving from where it is highly concentrated to where it is less, that is diffusion. The process by which it moves is diffusion. So if, for example, we are in one class, all of us, right now we are 57. All of us, imagine we are all in one class. When we start coming out of that class, we can say we are diffusing out of that class. We are spreading out, going to the rest of the environment. We are diffusing out. We were highly concentrated in one class, and now we've started moving out of that class, going to other places. We are diffusing because we were highly concentrated in one place. Now we are spreading out. All right. So let's look at the importance of diffusion, of which there are a number of reasons why diffusion is important. So diffusion is important in living organisms in the following ways. Number one, oxygen moves from the lungs to the blood, and from the blood to the tissue cells by diffusion. Carbon dioxide moves from the tissue cells to the blood, and from the blood to the lungs by diffusion. So what this point is saying is that when you breathe in, right, you breathe in oxygen. Now that oxygen, where does it go? It will go in the lungs. How does that oxygen move from the lungs into the blood? Well, it moves from the lungs into the blood by the process of diffusion. Where does that oxygen go after that? The blood will now transport the oxygen to the tissue cells. So once this oxygen reaches the area where there are tissue cells, it will come out of the blood going into the tissue cells. How does it come out of the blood going into the tissue cells? It moves by the process of diffusion. So you see, diffusion is taking place. That oxygen, which is going to the tissue cells, it is required in the process of respiration. Respiration, once it occurs, okay, what will be the product of that process or of that reaction? Carbon dioxide and energy. Now, carbon dioxide is toxic for your body. Therefore, it will diffuse out of the tissue cells going into the blood. And then that blood will transport that carbon dioxide to the lungs. Once that blood which contains carbon dioxide reaches the lungs will now then uh, diffuse the carbon dioxide out. Okay, excellent students, just give me a minute, I'm coming. Okay. Someone to please let me know if I'm audible enough. I'm back now. Someone to let me know if I'm audible. Wonderful. Okay. So yeah. So the first reason that I said, the first point that I said is a reason as to why diffusion is important is because oxygen diffuses into the blood from the lungs by the process of diffusion. Carbon dioxide diffuses from the blood into the lungs by the process of diffusion. Another reason is this: dissolved food moves from the blood into the tissue cells by diffusion. So when you put food into your mouth, you chew it. When you chew it, you swallow it. It goes into your stomach. And then from your stomach, it will go into the small intestines. Inside the small intestines, there's a stage of absorption under holozoic nutrition. This is just a stage where the nutrients from the food you ate are now taken up by the body, going into the bloodstream. So those nutrients are taken up by the body through the process of diffusion. So food nutrients are absorbed by the process of diffusion. And then another reason is metabolic wastes such as urea move from the tissue cells into the blood by diffusion. So urea is as a result of the deamination of amino acids. Okay, urea, and this is diffused out of the tissue cells going into the blood by the process of diffusion. Carbon dioxide needed for photosynthesis by plants moves from the atmosphere into the leaves by diffusion. So you find that plants, before they make their food, they will need the raw materials. They will need the materials to make their own food or to carry out the process of photosynthesis. One of the raw materials is carbon dioxide, and this carbon dioxide is found in the environment, coming from animals. So how do plants take that carbon dioxide? They take it out from the environment by the process of diffusion. So they take in carbon dioxide by the process of diffusion. And then oxygen produced during photosynthesis moves out of the leaves to the atmosphere by diffusion. So once photosynthesis occurs, one of the products of that reaction is oxygen, of which oxygen is not needed by plants during the day. Therefore, it has to come out of the plants. It has to diffuse, and it moves out of that plant by the process of diffusion. Although oxygen is needed by plants in the night, they take in oxygen during the process of respiration because the plants, they switch. In the night, they carry out respiration. During the day, they carry out photosynthesis. And then water vapor moves out of the air spaces of leaves to the atmosphere during transpiration by diffusion. So transpiration is simply the diffusion of water vapor from from the leaves into the atmosphere. So water vapor diffuses by the process of diffusion, of which excess transpiration leads to wilting. Otherwise, that is under transport in flowering plants. Yeah, so those are the reasons as to why diffusion is important, my excellent students. Okay, any questions? Are we clear? Are we clear? So in tomorrow's live class, I'm going to organize some questions, and these questions are just going to be random. Yeah, so they'll be mostly based on topics that are for grade 10, like the same diffusion, osmosis, active transport, homeostasis, enzymes, such questions. I mean, such topics. So make sure that you join even in tomorrow's live class because I'll be answering those questions. I believe at this point we have to answer more past paper questions, of which all the assignments that have been given you in the groups, they were all coming from past papers. So you've been answering past paper questions. That's the good part. You have been answering past paper questions. All you have to do is make sure that you watch the tutorial videos and study the notes. Like that's the most important thing. That's the most important thing. Otherwise, please, 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 please join me even tomorrow. I'll be live at 21 hours. So make sure that you join me. I hope the network will be good like the way it was today. And we're going to have a successful live class tomorrow. Otherwise, register for the online biology class for July. When you register, you're going to receive videos for the entire syllabus. Then, week one will be looking at ecology, genetics, and cells. I'll also teach on the microscope. Yeah, microscope. I'll also cover that as well as metabolic reactions, anabolic and catabolic. So make sure that you register for the online class for July. Otherwise, for this live class, we can call it a day and stay blessed.